Lesson 23, comparing means using dot plots. Alright, so first we want to know how to find the average or mean. First, what you want to do to find the average or mean is to add up all your data points. So here I have this example of 12, 15, 17, 17, 20, and 21. So the first step would be to add all of those together. So don't forget that you can type this into a calculator. So I have 12 plus 15 plus 17 plus 17 plus 20 plus 21. And I get 102. So the second thing we want to do is take your total and divide it by the total numbers that you added together. So I added 1, 2, 3, 4, 5, 6 numbers together. So I'm going to take 102 and divide it by 6, which means that my average would be 17. So for here, my average would be 17. Okay, so just a little recap or refresher of how you would find the average. Now, when you are finding the average from dot plots, it's the same exact process, except you don't have a list of numbers. You have to use your dot plot to determine what those numbers are. So like this dot would represent 62. I would have two 65s because I have two dots above 65. Here I would have 1, 2, 3 67s. I would have 1, 2 68s. Whoops. I would have 1, 2, 3, 4 69s. I would have 170 and 171. Now you don't have to make a list like this when you go to solve these. If you can read it right off the dot plot, that is fine. But we're going to do the same thing that we did before. So we're going to add up all of our numbers together, making sure that you're adding 67 3 times together. Okay, don't forget one. And then I always go through and just double check to make sure that I have all the right ones added together the right amount of times. And then we're going to find our grand total, which is 946. Okay, so what we're going to do now is we added together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers together. So I'm going to take 946 and divide it by 14, which tells me that the average height of this volleyball team would be 67.6 inches. This would be my average, so 67.6. The next dot plot represents the average height of soccer players. So we're going to do the same thing, except we are going to have different numbers. So I'm not going to write a list. I'm just going to use the dot plot to tell me what the numbers are. So that first dot is a 59. Second, I would have 61. Third, I would have 62. Fourth, I would have a 63. And then I would have 4 64s. So I'm going to add 64 4 times. I would have 3 65s, 1 66, 1 67, and 170. So here, when I add all of them together, I get 899. And then let's divide them by how many people are on this soccer team. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 again. So 899 divided by 14, which tells me that the average height of this soccer team would be 64.2 inches. This would be the average height of my soccer team. Alright, next question, we want to know how much greater is the average height of volleyball players than the average height of soccer players? Well, for volleyball players and then soccer players, our volleyball player average was 67.6 and our soccer average was 64.2. So if I want to know how much bigger the volleyball player height is, average height over the soccer average height, I would just want to subtract those two numbers. So again, feel free to type this on your calculator here so that you don't accidentally mess up any of your decimals. So if I have 67.6 minus 64.2, that is going to give me 3.4. So the volleyball team is 3.4 inches taller than the soccer team. All right, now our next question says that the average height of the volleyball team is about 67.6, and the average height in the soccer team is about 64.2. We know that the teams have similar variability in their heights, which means that the best estimate for the mean absolute deviation is what? So when we're talking about MAD, or mean absolute deviation, we're going to, if I were to add up my two heights, right, so I'm going to take 67.6 plus 64.2. Let me bring back my calculator. So let's add those two average heights together. So 67.6 plus 64.2. And then I'm going to take that average height and divide it by 2. And this is going to give me the mean absolute deviation for these two heights. Now, technically what we need to do here is figure out if this is our mean absolute deviation. What was it? 65.9? Yes. So this gives us 65.9. I need to figure out how far away these two heights are from 69.5, right? Meaning how many inches separate them. So to do that, I'm going to subtract them. And then for the second one, since this 65.9 is larger, I'm going to subtract it first. So again, feel free to use your calculator. So if I have 67.6 minus 65.9, and then I have 65.9 minus 64.2. They are both 1.7 inches away, which means that 1.8 would be the best estimate. Best estimate. Alright, now this question wants to know about how many mean absolute deviations are these two data sets apart. Well, if I were to draw a number line and have that 65.9 in the center, 67.6 over here, and 64.2 over here, we know that one mean absolute deviation is 1.8 inches, right? So this is one MAD. And then if I were to go another distance of my MAD, another MAD, I would have the distance between those two averages, which means I am traveling 2 mean absolute deviations apart. So the average height of the team is separated by about 2 mean absolute deviations. So the following dot plot shows the height of the players, right? So we use these dot plots to find the averages at the very beginning, and we want to know which statements best compares the data sets. Well, we know that volleyball players, the average, were taller than the soccer players, right? So I'm going to select that option right off the bat. So the average volleyball player is taller than the average soccer player. Let's read through the rest of these and see which other ones could possibly be an answer. It says the average soccer player is taller. Nope. The average volleyball and soccer players are about the same height. Nope. And the average volleyball player is twice as tall as the average soccer player. Well, that's not true either. So for this answer, or this question, the average volleyball player is going to be taller than the average soccer player. Alright, so now we're starting to drift away from those volleyball and soccer players, and we have a different scenario. It says that 2 samples involve daily temperatures in degrees Fahrenheit for 2 different cities in June. The mean absolute deviation for each data set is about the same, and the difference between the average temperatures for the 2 cities is about 3 mean absolute deviations apart. Okay, so think about this problem here, where these two numbers were fairly similar, right, and they were 2 mean absolute deviations apart. If I added another mean absolute deviation to make it 3, those two averages would be even further apart, right? So when we're reading through these answer choices, we want to keep that in mind. So let's see. We want to, based off this information, select which statements best compare the two data sets, and we want to select two that apply. A says that there's few temperature change values in common for these two cities in June. Well, I mean, it says here that the average height for the two cities, it says that two samples involve daily temperatures in degrees Fahrenheit for the two cities in June. The mean absolute deviation is about the same. So since they are about the same for their mean absolute deviation, I would say that they do have a few values in common, right? Think about when we found the averages of the volleyball and the soccer players. They had a few numbers in common, which is why their mean absolute deviations were almost the same. Now, the next thing that we want to look for is we want to kind of think about if there's a small difference or if there's a big difference in between the averages. Now, remember, since there's 3 mean absolute deviations away, these two numbers are going to be further apart. So since they're further apart, there's going to be a greater difference between the average temperatures. So yes, they have a few values in common, but there is a big difference between the averages because there are 3 mean absolute deviations apart. Alrighty, that is all I have for this lesson. Your quiz code for this upcoming quiz is going to be hash brown, okay, all lowercase, one word. And if you would like any extra help or have any questions, please let me know. Have a wonderful rest of your day.